Okay, so today we'll start looking at matter within chemistry. So really when you break down chemistry to its most simplistic definition, is chemistry is the study of matter and the changes that it undergoes. Okay, so what is matter? Well, matter is anything that has mass and takes up space or has a volume. Or we could just say matter is stuff, right? The stuff that's around us, everything that makes up space or takes up space and has volume, that's going to be matter. Okay, so let's break down matter a little bit further than that. So matter can be classified into two different subjects, or two different main large classifications. The first one being pure substances. Okay, so under pure substances we have two classifications. You can have elements, or you can have compounds. Okay, so elements are found on the periodic table of elements. Okay, so if they're not listed on the periodic table explicitly, then it's not an element. And elements are the smallest unit or the simplest unit of something that has the exact same properties and compounds. So really what we're dealing with here is atoms with the same number of protons in the nucleus, and that's going to be an element. Okay, so then your other pure substance are compounds. Compounds are just two or more elements chemically combined. So they're bonded somehow. Okay, and when you make a compound, all the stuff from the elements, the properties of the elements change when they become a compound, once they've been chemically combined. So other than pure substances, so we have pure substances, and then we also have the other large classification is mixtures. And under mixtures, we're going to have two classifications. You're going to have homogeneous and heterogeneous. Mixtures. So homogeneous mixture is the same throughout. Okay, so a homogeneous mixture you can't tell one part of it from the other. Some examples of this would be like air, salt water. Okay, you know, with air, okay, on a small scale level, not on the whole entire atmosphere of the Earth, but like in the room that you're in, you can't say, hey, the air on this side of the room has more oxygen than the air on that side over there. Okay, so within the smaller quantities, air is a homogeneous mixture. And then like salt water, if you take a glass of salt water, if you look in the ocean, you can't say, hey, this part of the salt water is saltier than that part of the salt water, because it's the same throughout. It's mixture. And really what mixtures are is a combination of two or more pure substances that are not chemically bound. So these are not chemically combined. Okay. And a heterogeneous mixture would then be different throughout, or not the same throughout. Okay, so when you're dealing with something that's not the same throughout, some examples of that would be sand. The mixture we had the other day in lab, you could see individual parts of it. You could have salads, non-chemical examples, of course. You know, salads. You can look at a salad, and you can see the leaf and the ranch and the tomato and all that kind of stuff. Mud would be one. Different aspects of the mud would be different. So there's some examples of a heterogeneous mixture. So Chemistry is the study of matter and the changes it undergoes, and matter can be classified in these two things. You've got pure substances, elements and compounds, mixtures, and under mixtures you've got homogeneous and heterogeneous. Okay, so now let's look at the changes. So that's kind of the classification of matter, but let's look at some of the changes that matter can undergo. Okay, the first change would be physical changes. Okay, a physical change is a change that does not change the identity of the compound. Or in other words, what you finish with is what you started with. Okay? Some examples of physical changes are freezing, melting, so all phase changes, boiling. Also size changes. If you crush something, or you grind something up, or if you rip something or shred something, these are all examples of physical changes because you still have what you started with. You know, if I take a piece of paper and I rip it in half, I still have a piece of paper. It's just in two different sizes. Okay, that would be irreversible physical change, but still a physical change. And here's an example of a phase change. So we've got the three phases of water. So if you look at water, water is H2O, right? You guys know this, H2O. And if you draw water out, normally it's drawn like this, with the larger atom being red, and then the two smaller ones being white. Okay, so 1 part oxygen, 2 part hydrogen. So if you look over here, we've got the three phases of water: ice, solid water, liquid water, and gaseous water. And if you can see in all these, they still have 1, 2, so 2 hydrogens and 1 oxygen per molecule. If we kind of look at one molecule here, maybe this front one right here, we got 1, 2, 2 hydrogens, 1 oxygen, so per molecule. And this one's a lot trickier to see because they're kind of stuck together, but you have, you know, 1 oxygen and 2 hydrogens here per this one water molecule. Okay, so even though it's changed when it's gone from solid to liquid, okay, it still has the same properties. You still have that basic compound the same. Same thing is true when it goes from liquid to gas. Okay, so physical change, dissolving would be another physical change. That'd be a big one. Okay, so chemical change. Well, how do we contrast that with a chemical change? A chemical change is when a new chemical bond is made. Or you can say a new substance is formed. Okay, so something about it is changed and you have a new substance. Some examples of chemical changes are like when you cook something. Say you have an egg and you cook it, you fry an egg. Well, you know, something is different about a cooked egg than a raw egg. Okay, or if you burn something, if you take a piece of paper and instead of ripping it this time, which is a physical change, say you light it on fire. Well, the ash is new. It's a different substance that's been formed. Okay, if it reacts with an acid or if gases are produced or something like that, these are all chemical changes. So if you look at a particle level down here, what we have here is this is how rust is made. So you have iron, okay, just solid iron, just like that as atoms. And then you add some oxygen molecules, some O2 molecules. Okay, and then what you get is now you get this iron molecule bonded to 2 oxygen molecules. Okay, and you get Fe2O3. Okay, this right here, this iron-oxygen connection, was not existent over here on this side. Okay, so that's a chemical change. And also, if you think of rust, okay, do you want a rusted out car? This is rust. No, you don't want a rusted out car because the properties of this are different than this. Okay, you know, it flakes apart, it's not very sturdy, all that kind of stuff. So a new chemical is formed, all right, and a new substance is formed with new physical and chemical properties. So that's a chemical change. So some chemical changes, like I said, so anything that burns, so burning, Reacting, normally if it says something that reacts with something else, that's an indication of a chemical change. This is an oxidation reaction. It's rusted out. Okay, some indication that some of these chemical changes have occurred. So how do we know? So how do we identify them? So indicators would be production of light, of a gas, effervescence. Okay, if a new smell is happening. Okay. So those are all some indicators when physical chemical changes occur. Okay, so now we can break that down into physical properties and chemical properties. So we have chemical and physical changes, and we also have physical properties and chemical properties. So physical properties are, they can be observed without changing the substance. Okay, so physical properties can be observed without changing the substance, such as color, size, density, boiling point, melting point, freezing point, on and on. Okay, so you still have the original substance that you started with. To contrast that, chemical properties Okay, so physical properties you can observe without changing the substance. Chemical properties you have to observe by completing a chemical reaction. Okay. So an example, a physical property is my shirt that I have right on here is blue. Okay, you guys can see it. That's a physical property. It's a blue shirt. Now, if I want to know the chemical properties of this, say I want to know like how fast does it burn. Well, in order to observe that, I've got to light it on fire, right? So that would be a chemical property. So how does something burn? Okay. Or how does it react with acid? And that would be another thing, or those are just two examples of some chemical properties. So anytime with chemical properties, normally it says, hey, how does it react? Okay, does it react with a metal? Does it react with water? Or stuff like that. So chemical properties. And how do we observe them? By completing a chemical reaction. Okay, so there's a general overview of matter. And remember back here, why are we talking about matter? Well, because chemistry is the study of matter, right, and the changes it undergoes. So we have those two classifications, pure substances and mixtures, and two types of changes. We have physical changes and we have chemical changes. All right, hope that made sense. If you guys have any questions during lectures and stuff like this, make sure you write them down so then when you see me in person, we can go over those questions. Hope you guys have a great day.